Hello. The title of the presentation is Detecting Learning in Noisy Data, the case of oral reading fluency. I'm Beata Beigman, and this is joint work with a lot of colleagues at Educational Testing Service and in some other places. Let's start with an overview. We will first talk about the motivation for this work, which is unobtrusive detection of learning using technology. We will then describe the instrument that we developed. It's called Relay Reader, available on relayreader.org. And we describe the design of the study and how we measure oral reading fluency and the kinds of models that we use to model growth or improvement in oral reading fluency. And we will share the results. So in institutional educational contexts such as schools, learning of a skill is usually tracked through a series of tests that are especially designed for that particular skill. This is the case for tracking development in oral reading fluency. For example, DIBELS, a popular test that includes oral reading fluency as one of its components, has the readers read aloud 1 to 3 test passages to the teacher who's administering the test, one-on-one for every student. This kind of test is administered in fall, winter, and spring every year throughout elementary school to allow progress tracking. So this does take a fair amount of school time to administer these tests. So the question is, can we detect improvement in oral reading fluency when children are reading, doing the actual thing, and not just doing test passages for test? So how can this be done? And this is our proposal. We would have children read a full-length book for pleasure and learning in a relay format, which means taking turns reading aloud consecutive passages from the book with a pre-recorded skilled adult narrator. This activity will be taking place regularly as part of the curriculum. In the United States, many elementary schools have independent individual reading slots for up to 30 minutes, sometimes called DEAR time, drop everything and read time. While children are doing this, their oral reading is recorded and stored for further analysis. And that further analysis can hopefully show that they are improving. So the next slide is a description of Relay Reader, the app we have built to implement this idea. So let me play some of the audio to you.
Relay Reader is a reading and listening app built to help you become a more fluent reader while enjoying a good story. Relay Reader is available as a web app or as a mobile app. You can start on one device and continue on another right where you left off. Put on your headphones, sit back, and enjoy listening to the beginning of the story.
Centuries ago there lived a king, my little readers will say immediately. No, children, you are mistaken. Once upon a time, there was a piece of wood.
The highlighting in the text will help you follow along. You can pause and replay if you miss something. When the narrator is done reading his section, it is your turn to read aloud. Begin reading at the line marked with the pink speaker icon and continue until you cannot scroll any further. What a look of surprise shown on Mastro Chair. Many of the words on your page you have just heard. Those would be easy to read. Answer some questions based on the text to help you stay focused, strengthen your vocabulary, and recall some of the important points. Select your answer and click Submit. Reading history shows your progress. You can see how many pages you read, how many questions you got right, how far you have progressed in the story, and how long you have been reading. Select a chapter from completed chapters for review. The app shows you the passages you listened to and the passages you read. You can listen again to the narrator reading their passage. You can listen to yourself reading your passage. See if you catch any errors. You can also listen to the narrator read your passage and get inspired. Ready to perform? Re-record your turn. Finally, you can see the questions that are related to the passage and your answers. Try to read at least a little bit every day so that you do not forget what is going on in the story.
Okay, so this is Relay Reader, and the web app is already available on relayreader.org/app. The mobile versions are heading to the App Store and Play Store soon. Now let's continue here. So for this study, we had the upper elementary students in New Jersey school, in one New Jersey school, read with Relay Reader, each child reading on a personal Kindle Fire 7 device. We had 4th and 5th graders in the group. They were reading Harry Potter and the Sorcerer's Stone with Jim Dale's narration in the relay. Harry Potter is not available in the public app. The public app has The Adventures of Pinocchio, as you saw in the video. The duration of the study was about 15 weeks. By that time, 95% of the students finished the whole book, reading 3 to 4 times a week, about 20 minutes at a time. And actually, the 95% of kids who finished the book is in itself quite an achievement, because for some of these kids, this would be the first real long, thick book that they have read. It's 80,000 words worth of reading experience. So this slide shows that kids generally didn't see this as a burden. They enjoyed the activity and they persevered with it happily. These come from a survey we administered to all participants in the end of the study, and they were asked to strongly strongly disagree, agree, or strongly agree with each of the statements, and we coded strongly disagree as 1 and strongly agree as 4. So what you see here are average ratings. As you can see, kids liked reading with the app. They liked listening to the narrator. They liked this relay format. And they also thought that this app helped them become a better reader. So they were conscious of the fact that they were reading a pretty complex book all by themselves with the narrator's help. They also gave low ratings to statements like the book was boring. They didn't think so. Or I prefer to read by myself without the narrator, though not really. And the usability of the app was also pretty good, because they said that it was not difficult to use. Okay, let's see how we actually measure oral reading fluency for all those recordings collected during the reading. Fluency is usually measured as words read correctly per minute. So if you omit, substitute, or mispronounce words, they are marked as errors and are not counted towards words read correctly. When you put an extra word that is not in the text, or just hesitate for a long time, you're penalized through duration, because it does take time, but it doesn't contribute to your count of correctly read words. And for dibbles, teachers are the ones administering the test, so they are timing the reading, they're marking the errors, they're computing what's correct per minute. But speech technologies have been successfully used for scoring reading fluency automatically, such as MOBI, usually under quiet monitored conditions. So what are the challenges in unobtrusive tracking of oral reading fluency in our study? So first, we have no control over the properties of the passages. Everybody's reading Harry Potter and we cannot change a single letter there. Now, it's a problem because it is known in the reading literature that what you read impacts how you read it, including your reading rate. And we also know from our own prior study that this particular book varies a lot in textual features from page to page. So we specifically looked at text complexity, and we saw that in Harry Potter you have everything from grade level 2 complexity to grade level 12 or 11 it was maybe complexity, so really a large variety of passages and features there. Secondly, different readers end up reading different passages. So again, this is making things a little difficult for measurement because there isn't a single text that everybody is reading. And this is because every reader is progressing through the story at a different pace. So you have an allocation of 20 minutes per day. Some readers will read more during this time than others. And the app is built in a way that every time you log in a new day, it will always start with narrator turn to ease you into the activity, whether or not in the previous day you were the one to finish reading or the narrator. So you can see how we get divergence in the passages that kids read pretty quickly. Plus, there is also a way to change the length of the turn for yourself and for the narrator, which is also adding to this variety. We'll talk about it later. Next, there is a substantial technical, acoustic, and behavioral noise in this activity that has to do with this being a regular class activity that is taking place over an extended period of time, so it's not really feasible to maintain special or quiet settings for this. One day you're sitting under an air conditioner, another day there is some noise in the corridor and something else is happening. There's just a lot of noise coming from this. Plus, children are doing individual, independent reading. The teacher is there and she's watching over them, but not individually any particular child. And so if today I'm not in the mood, I'm just muttering to myself and the recording is not good then, or I'm even like reading completely silently, or I'm reading only half my turn, or I'm singing it today, or what have you. So we've seen a lot of different behaviors there. So that also contributes to many issues in the recordings. We call this behavioral noise. They have a prior paper about this as well. So the goal of this study is to assess feasibility of tracking oral reading fluency using data collected through Relay Reader in the face of all these challenges that we just mentioned. Okay, so the first one was controlling for text effects, and we use two measures in our model. One is the text complexity estimated with text evaluator, we call it TE. The finding in the reading literature is generally that more complex texts are read more slowly because it takes you more time to follow the story and comprehend what you're reading. So much so that in testing oral reading fluency, test passages are selected or even constructed to match desired text complexity levels. So in DIBELS, you have certain passages for grade 1, other passages for grade 2, etc., with a fairly tight control of the complexity there. The second constraint, or the second variable, comes from phonetics. that is telling us that oral production in English has certain regularities that have to do with some phones that are being uttered faster than others. So takes longer than say. So the phone level, word level regularities, as well as at higher levels, such as phrase and sentence. So you have phrase and sentence final lengthening, and there are also pauses between phrases and sentences, etc. So all of these normal operations of oral production in English are modeled in good text-to-speech synthesis systems. So we're using one such system, and the variable is the words per minute, the reading rate of such a synthesizer. So we call it TTS in the models that will follow. So in the analysis that I will be presenting, we treat chapters as a measure of time. And this is better than treating the actual time, because during any particular time unit, we have a lot of variability of who is reading what, whereas if we go by chapter, we do have a better chance of multiple people reading the same passage because they're at least restricted to the chapter. And also we know that these chapters were read in sequence because the app did not allow readers to jump forward. There is more discussion about this idea in the paper. So our research question is there significant growth in oral reading fluency over time, or in this case over chapters from chapter 1 to 17? For the first analysis, we pick 35 out of our 42 readers who read on a similar schedule. By schedule here, I mean the length of the turn for the reader and for the narrator. So the standard schedule was 150 words on average for the reader and 200 for the narrator. The other 7 children were reading on a shorter schedule, about half of those lengths, or more specifically 70 for children and 150 for the narrator. We don't know what the effect would be of a systematic difference in length of the passage. So for this first analysis, we just looked at the 35 who were having similar lengths of passages. For these children, we took all the recordings that corresponded to 68 passages that we picked, 4 in every chapter, that were distributed in the, throughout the chapter and had the largest number of kids reading the same passage. Again, there is more about the selection of those passages in the paper. And these 1,556 recordings were manually scored for fluency. So the first analysis is a relatively limited set of data manually transcribed to see whether in the cleanest conditions that we can get here, we can see improvement and the extent of it. Analysis 2, we are removing some of these constraints. So we are going to do automated scoring of fluency. We are going to use data from all our 42 readers, using all the data that is usable following this automated scoring procedure. There is a lot of detail in the paper on what usable here means. So before we dive into statistical modeling, let's just have a quick look at what the data actually looks like. So you have chapter on the x-axis and standardized fluency on y. And each data point is an average over all the readings that we have for the 4 passages that belong to that chapter. As you can see, there is a clear upward trend from the beginning of the reading towards the end, so things look good. For modeling growth, we use mixed linear models with random effects for students and for passages. Chapter is both a fixed factor and the random slope. So you see this chapter by student element in the model in order to allow students to have different growth rates across chapters. So a full definition of the model is found in the paper, but this is just telling you that passage and students are random effects and grade, text evaluator, TTS, and chapter are fixed effects. So analysis 1, selected manually scored data. We do observe a significant chapter effect, improvement of about 1.28 words correct per minute per chapter. You see it in the model where the arrow is pointing. So if you aggregate this over 17 chapters, that's about 21, 22 words correct per minute. Improvement from chapter 1 to chapter 17, which is roughly what you would expect based on oral reading fluency norms. And again, there's more about this in the paper. So what happens when we move to analysis 2? So we do still have significant chapter effect, and it is even nearly the exact same magnitude. So instead of 1.2 something, we have 1.1 something. And this is using about 4 times the amount of data, as you can see in the line that says observations. So to conclude, we have extensive but noisy longitudinal oral reading data that was collected from upper elementary school children during multi-week book reading with Relay Reader, which is an app we built where a child is taking turns reading a book out loud with a model audiobook narrator. We show that these data can support detection of improvement in oral reading fluency using automated means, despite lack of control over text and substantial environmental and behavioral noise and imperfections of the automated speech recognition technology. So I believe this result is very encouraging, as it is bringing us one step closer to realizing the vision of technology-based unobtrusive assessment, where you're just doing the real thing and the system is making its calculations in the background without intruding on your experience and without having you set a special test for this. Okay. Thank you very much for your attention. Please feel free to contact me with any questions and comments right after the lecture if this is going to be played at the conference, and also afterwards. Also, do consider using Relay Reader for your developing readers who are currently at home due to the coronavirus lockdown. The web app is available, and it is free. Thank you very much.